Good morning, everybody. It's an expert Friday morning. We're using the Microsoft Sudoku. I don't even know if I pronounce it correctly, but I got a system here that I think you'll enjoy. For some of you who are uber organized, then you're going to like this little system whenever you're doing handwritten puzzles. You can employ this system. You start off by simply counting the number of each of the 9 numbers the puzzle starts by giving you. Therefore, every time you add any one of the numbers, you just put another tick mark. There's a total of 9. When you've reached 9, you know that you've completed all of that particular number. When you complete a row, which is side to side, put a check mark to the right after checking it for accuracy. And there's 2 examples there. And when you complete a column, there's 2 examples here. Put a check mark beneath it. And whenever you complete one of the 9 3x3 boxes within the overall 9x9 matrix, put a little mark on the top right-hand corner. Here are 3 examples of at this stage of the game where that's been completed. And then if you're grading an overall puzzle after the fact, you can wait until the end to do the same thing. It's redundancy upon redundancy upon redundancy, but actually, if you do it enough, you'll be amazed how you'll learn the puzzle even faster, or learn Sudoku. But Sudoku is always an ongoing challenge. This is an expert puzzle. We know we play a little game within the game here, and this one does not allow us to do it that way because it gives us the one in the middle column or the center column of cells. So then what I like to do beyond that is if they don't give us that middle one, we're going to try to get rid of the ones as quickly as we can because we're mad. So I hope everybody's looking forward to a productive and good good weekend, spending time with your friends and family, if that's what you choose to do. And I think we're going to be able to get rid of the ones here. This is, I got Sirius Satellite Radio in the background. They actually are interviewing Tom Coughlin, which I can't multitask, but I enjoy listening to him. Okay, so we're right here. So we're done with ones, thank God. Okay, now let's see. The smallest number beyond that is number 7, has only 4 remaining. So it's actually backwards here on this puzzle. They count down with the numbers that are remaining. So we look for the smallest number. It's a different way to look for volume. So there's only 4 7s remaining. Let's see if we can solve for that. 7 7. That doesn't look like we're going to be able to do that. Let's see. Don't give up. Don't give up. There and 7. Yeah, it's all over the map the way it is. So we're not even going to make. I don't think we're. Yes, we can make notations. 7. They can either 7 in that top box can either be there or there. Only one of 2 spots. But we don't have enough information to make our notes any way we generally like to make them. So let me see. Oh, there's 3 there. So let's go back and find out how many have 5 remaining. 3 and 5. The numbers 3 and 5 each have 5 remaining. So 3's, let's see, 3 there and there. No, there and there. Well, here we go. We can make 3's here. If you look below in the description, there's a lot, by the way. I've actually got to potentially repair one of the links, but lessons 1, 2, 3, and 4 of this puzzle will tell you about 90+%, and the other 50% with regard to Sudoku is basically ongoing learning. And if you come and visit us every now and again, you never know, you might pick up some tips. We might pick up some tips as we're filming to share with you. So, yeah, I don't feel good about the threes. We just don't have enough information. It's leaving us with a minimum of 3 in a box that does not already have a 3. So, let's see, 3 cannot be there, it cannot be there. Well, we've narrowed down this right-hand column of cells within the middle column of boxes. I think we 3 cannot be there, it cannot be there by virtue of these 2. So that leaves us to 3. So 3 can be there, or it can be there with regard to that column of cells. Not a great bit of deal. Well, let's move on. Okay, what do we say? 5, okay. Let's see 5s. So 5, 5, and 5. 5, 5, and 5 can either be here or here. And then 5 we know can be, let's see here. With regard to this top right box, by virtue of this 5 here, the 5 can either be here or here, which means the top box, it can either be here or here. And now let's look at this. Now, 5 cannot be there, cannot be there. Yes, so 5, with regard to the same right-hand cell, right-hand column of cells, 5 can only be in 2 spots. Is he going to be there or there? Can't be there by virtue of the next door neighbor there, and it can't be there by virtue of this 5 over here. So that's about 1, 2, let's see, 3, 4, 5, 6, 8. No, can't do that. I just see 8s. I need to get out of my system. I need to draw a couple 8s. So there's a couple left-handed 8s. So 8 and 8. In my advanced age, I try to do different life, I think you guys call them life hacks these days. And one of those is to use my left hand for things I don't normally do. And I don't normally use my left hand for writing. So it's good therapy early in the morning. It's not even that early, but it's what? It's about 5:20, I think it looks like. It's closing in on 5:20. So 8s can't be there. We don't have enough 8s. I just needed to do some 8s. Okay, let's go back to it. 5s, okay. Well, let's look at 6s. 2 and 6. Each have 6 remaining. Let's look at 6s. 6 and 6. I don't have any 6s in the middle yet. The middle column of boxes. 6, 6, and 6. Here we go. Left column of boxes. Solve for 6. Therefore, solve for 8. So that's a good thing. That was a good thing. I don't see that many more opportunities for 6s. It can be in either one of these 3, but we're not going to write 3 6 notes. So let's see. 6 can be there. It can be in all 4 of those. Let's look at this middle row of cells within the top row of boxes, because we're down to 3. 1, 2, 3. So 7 can't be here, and 7 cannot be here. So therefore, with regard to that row, 7 can only be here. Okay. 1, 2, 3. 4 is missing. Well, 4 has to be there. 5, 6, 7, 8, and 9. There's a perfect example. We honed down. We looked for volume. There were only 3 cells in that middle row of cells within the top row of boxes. So we were able to solve for it because we were simply looking for volume. 3 of the 9 were remaining. So 2/3 were complete within that cell. I hope that makes sense. Let's do the same idea, same thinking down here at the very bottom row of cells on the entire puzzle, or the bottom row within the bottom row of boxes. So we've got, again, 3 missing. 2 is one of the 3 missing numbers we don't have. Oh, wait. 2 can either be here or here. Cannot be there. Okay, so 1, 2, 3, 4, 5, 6, 7. What about 8? Okay, 8 can either be here or there. So let's start doing notes. 2 can either be there or there. By virtue of this 8 here, 8 can only be there or we're having problems. And 8. Okay. So what's the last number? 9 is the number that's missing. And 9 cannot be there. So now we have pairs. See? The 2 and the 9 for different reasons. The 9 is in this box and the 2 is in this column. So neither the 2 or the 9 can be here. So, oops, wrong number. And 8, get rid of the 8s because the 9's making it so that we've solved for this 8. A different way to look at it before, let's take the 8 away and let's look at it this way. You could have randomly picked this cell and said, let's see what can go into this cell. Can the 1 go in this cell? Answer's no. Can the 2 go in this cell? Answer's no. Can the 3 or 4 go in this cell? Answer's no. Can the 5 go in this cell? Answer's no. 6, 7, can it go into this cell? No. Can the 8 go in the cell? So far, yes. Can the 9 go in the cell? No. So by doing that, that's pretty crude, but it tells us the only number that could go in that cell is the number 8. I'll randomly pick another cell and do the same thing. Let's pick this cell right here. Since I see just randomly that 1, 2, and 3 cannot go in that cell because they're in the same box. So 1, 2, and 3 cannot go in the cell. Can 4 go in the cell? No. Can 5 go into that cell? No. Can 6 go into that cell? Yes, it can. Can 7 go into that cell? No. Can 8 go into that cell? Yes, it can. Can 9 go into that cell? Yes, it can. Well, we've got 3 numbers that can go in that cell, so we're not making a note with any of those. So those are some examples. All right, let's get back on track. What are we missing here? What are we missing? Let's revisit 7s. I doubt that we'll have enough, but you never know. Now, this left-hand column of cells, okay, left-hand column of cells, or the left-hand column of cells within the left-hand column of boxes, 7 can't be there, 7 can't be there. Well, automatically we know 7 therefore can only be there or there in that column. It has to be 1. Can it be there? Yes. Can it be there? Yes. So we'll make a note. 7. 7. So we got some cross-contamination because they're in different boxes, but they're in the same column of cells. So let's continue. Well, 7 is solved for as far as this right-hand column of boxes. 7 is solved for as far as this middle column of boxes. And as far as the left-hand column of boxes, there are no 7s. We have notes. Oh, wait. Check this out. 7 can't be in either one of those two, so automatically 7 has to be here. Here we go. 7. So that's a beginning. That's a beginning. Now, 7 can't be in either one of those two. These two 7s say 7 either has to be here or here. All right. Same over here. We got a 7 bottom row of boxes. We got a 7 on the top. We got a 7 on the bottom. 7 needs to be in one of these 3 cells right here. Can't be in that one, so we're down. We can make a note for 2. That's our own little policy of making notes. You can make notes if you get on the Microsoft Sudoku puzzle. You can make notes to your heart's content. But that's just a little internal policy. So we're down to 2. We went from 3 to 2, 7s. All right. What's the next smallest number? It looks like 5 is the next smallest number. 8, 6, 5, and 3 each have 5 remaining. This is a difficult puzzle. That's why they call it an expert puzzle. So don't let it intimidate you. Let's see if we've got any more information. 5s. Okay. 5 cannot be here. 5 cannot be here. So with regard to this right-hand column of cells within the middle column of boxes, the 5 can only be there or there. So now we've got 4 blanks in this column, 4 empty cells. So let's see. 1, 2. Can the 3 go here? No. Can the 3 go there? No. But it can go in either one of those 3. What about 4? What about 4? Look at 4 can't be in either one of those 2. Do we have enough information? No, we don't. So 4, again, we're looking for potential pairs. We're not going to find it here, but 4 can either go there or there. 5. We already know about 5. What about 6s? 6s. 6 can be here. 6 can be here or here. It's already 3. And who knows? 6 can be there. 7, 8, and 9. So let's look at this cell right here. We made no notes. Can 1 go in there? No. Can 2 go in there? No. Can 3 go in there? Yes. No. Can 4 go in there? No. Can 5 go in there? No. Can 6 go in there? Yes. 7, 8, and 9. 6 is the number. Now, oddly enough, aside from completing that cell and reducing 6 now in this right-hand box, it can only be here